13.2 added to 0.25 plus 1.261 plus 8.04. It's a very simple process. What we do is we write down the first number, 13.2, and then the rule is we line up the decimals. Just line up the decimals. So the next number is 0.25. Third number is 1.261, and the fourth number is 8.04. And we just add. Okay. All right. Here's the decimal place. And this is first all tenths and hundreds and thousands. So we're lining up here. We add down here, which would be 1. And then this column would be 6 and 4 is 10, plus 5 is 15. Carry over 1. So that's 3, 5, 7. Decimal place goes right where the decimal place is. And then adding up these will be 12, carry over 1, which is 22.751. Very simple process. Point being, when you add or subtract decimals, you line up the decimal places and then either add or subtract. All right, let's look at the next example. The next example, 0.37 plus 1.2 plus a half, is what we need here is to change a fraction into a decimal. And 1/2 is 0.5. And if you don't know that, later on in this tape I will show you how to find that out by long division if you don't know these decimals for certain fractions. So I will show you on the tape how to do that. Alright, so what we do then is we line up 0.37 and 1.2 and 0.5. And we add up 7, 3 and 2 is 5, and 5 is 10, carry the 1, 2.07. Alright, looking for the next example. The next example is where we have some sum or 1 subtraction part of it. So first thing to do is to change this to 0.25. Right, so we have 0.326, 1.62, and 0.25 to add. So we add that, this would be 6. Adding this would be 9. Adding this would be 11. Carry the 1, 2.196. All right, then we have a subtraction. So you can rewrite this, or right here you can say, okay, now we'll subtract 0.43. Again, lining up decimals with decimals. Subtracting, this is like a 0. So subtracting that would be 6. This would be 6. Subtracting here, we have to borrow 1 and make that 11, so that's 7. And then we borrowed 1, so that's now 1. So that's 1.766. All right, next one. Okay, the next one is 0.326 plus 1.62 minus 2 different numbers. So what we do, one way of doing this is to line up the decimals. 0.326, 1.62. We'll add those. So adding here would be 6, 4, 9, 1. Now what you can do is this. Now subtract this one. So we're going to subtract point, line up the decimals. 4, 3. This is like a 0, so that's 6. 3 from 4 is 1. 4 from 9 is 5. 1. And then subtract the other one, minus 0.181. 1 from 6 is 5. 8 from 1, we have to borrow 1, it's 8 from 11, so that's 3. We borrowed 1, that's a 4 now. That's a 3. 1.335. Okay, so that's a pretty simple process of adding and subtracting decimals. Simple concept of lining up decimals above decimals, and then just adding and subtracting. Now let's look at the
concept of multiplying decimals and dividing.
So let's take this first. So what I would do is write down 1.26, and then the way you line this up is the last digit here goes under the last one here. And you multiply. Now forget about the decimal, just multiply numbers like you do regular multiplication. So 3 times 6 is 18, carry my 1, so that's 7. 3 times 1 is 3. 4 times 6 is 24, goes underneath the 4. 24, carry my 2, that's 10, carry my 1, so that's 5. So we now add, so this will be 8, 11, carry my 1.
Now, here's the trick to multiplying decimals.
How many decimal places does this number have? It has 1, 2. This one has 1, 2, 3. So it's 5 in all. So I've got to start from behind the last digit and go 1, 2, 3, 4. So I have to add a 0 to make it 5 decimal places. So when you multiply, you simply count up how many decimal places this one has, how many decimal places this one has to make it a whole number. And you add those, and that tells you how many places to count on your final answer. All right, so let's take a couple more examples. Next example is 21.4 times 0.51. So put 21.4, and I'll put the 1 and the 5 here. Just lining up the numbers now, don't line up the decimal places. Alright, so 1 times 4 is 4, 1 times 1 is 1, 1 times 2 is 2. 5 times 4 is 20. Write down the 0, carry a 2. 5 times 1 and 2 is 7. 5 times 2 is 10. And adding, this would be 4, 1, and 0, 1. Now come back up here and add decimal places. How many places it take to get it where it's not a decimal number? 2 and 1. It's 3 in all, so I come down here, start here, go 1, 2, 3. So my answer is 10.914. All right, let's do one more. On multiply. So we have point. Now here's where I do things like this. I write down 12.5 and put the 2, 1 underneath it. Because this way I only have to multiply twice, the other way I have to multiply with 3. So you don't have to put the first number first. You simply put one number underneath the other one, and then go multiply. 1 times 5 is 5, 1 times 2 is 2, 2 times 5 is 10, carry 1, it's 5, and 2 times that. And I add, I get 5, 2, 6, 2. Come up here and count, 1, 2 decimal places, 1, that adds up to 3. So start here and go 1, 2, 3. Hey, check your answer to see if it's reasonable. Look at what we have. We have 12 times less than 1. So the answer better not be 26. Okay, and then that's about 2/10 of 12. So 2/10 of 10 is 2. So that looks sensible. So, you know, when you work numbers, I don't see if it's sensible. All right, now we're not through with this. We now have to take this answer and multiply it by 0.27. So multiplying by 7, we get 35, carry my 3, 14 and 3 is 17, carry my 1, 42 and 1 is 43, carry my 4, 14 and 4 is 18. 2 times 5 is 0, carry my 1. 5, 2 times 6 is 12, carry my 1, and so I add. So we get 5, 7, 8, 0, 7. And what I have up here, 1, 2, 3, 1, 2, so that's 5 in all. So that's 1, 2, 3, 4, 5. All right. Now let's look at division. All this, I know you probably know how to do all this multiplying and adding numbers. All I'm trying to do is point out some of the little rules about where the decimal place goes. So let's now look at the division of 0.23 divided by 0.451. So the way I guess you were taught is put it down in what's called long division. Now here's what the rule is. How many decimal places of this need to be moved where it's not a decimal number anymore? That's 1, 2, 3. So you move this over 1, 2. Oops, we got to add some zeros here. So let's go back. 1, 2, 3. So right here, we're going to think about the decimal place. Okay. So let's rewrite this problem now. This would be 4, 5, 1. Write it into 2, 3, 0, decimal, 0, 0, 0. And where you have this decimal place now is where the decimal place goes in the answer. And now we don't have to look at the decimal over here, and we say, okay, how many times will 451 go into 230? How that would go? So how many times will 453 go into 51, go into 2,300? And let's say that looks about like 5 times, so let's put a 5 there. 5 times 1 is 5. 5 times 5 is 25, carry my 2. 5 times 4 is 20, plus the 2 is 22. And you subtract, you get 5, 4. You bring down the next term, which is a 0, next number. How many times will that go into that? No, it won't go into that. So we're going to put a 0 there. And then we bring down the next number. Now take your time and don't miss something like that. You bring down that first one. You say how many times, it won't go. Go put that 0 up there before you come down and bring down another number. All right, now how many times will this go in this? This will go 9, and then 9 times 1 is 9. 9 times 5 is 45, carry my 4. 9 times 4 is 36, and 4 is 40. And 9 from 0 is 1, 4, 4. And you keep on going. You can follow that. Point being is, we move the decimal place over 3 places, place it where it belongs now, and then start working the problem. All right, let's look at the next example. The next example is just another way of writing it. It says we want this divided with this. So what we'll do is put 78, and we'll put 1, 4, 3, 5, 0, 0. And notice, this is how many places? 2. So in this number, we'll move it over 2. So the decimal place goes between the 3 and the 5. What I'm trying to make a point of between this one and the one before is the divisor, this number that goes on the bottom, this number that goes over here, tells us how many places to move the decimal place, not the first number. All right, then we say, okay, well, how many times does 78 go into that? It's like 1 time. 1 times that's 78. Subtracting is 5. That makes that 13, so that's 6. Bring down the next number. How many times will 78, or about 80, go into 60? And that's about, 7 times, 8 times. About 8 times, all right? So 8 times 8 is 64, carry my 6. 8 times 7 is 56, and 6 is 62. Subtract, we get 1, 31. Bring down the next term. How many times will 78, or about 80, go into 310? And the answer is around 3. So 3 times 8 is 24. Carry my 2. 3 times 7 is 21, plus the 2 is 23. And subtracting, we get that. And you bring down the terms and keep going. You can continue that way. Point being is, in division, you move the decimal place here 2 places, line up decimal place with decimal place, and then go through your regular long division. Okay, the last example now is showing you how to take that fraction that we talked about earlier. If you don't know what 1/4 is, or 1/2, or 3/16 or something, this is how we can find out. We just use long division. 3/8 is 8 divided into 3. Now, if we don't have a decimal number, it's always considered right there. We don't have a decimal here, so we don't have to move it. Therefore, the decimal goes above the decimal and we take off. 8 will not go into 3, so we don't put any number there. Now 8 will go into 30 3 times. That would be 3 times 8 would be 24. Subtracting 6, bring down the next 0. 8 into 60 will go 7 times. 7 times 8 is 56. Subtracting, get 4, bring down the next 0. 8 into 40 will go 5 times. And that's 40. Look, hey, no more numbers to fool with. This is a terminating decimal. It stops. We don't have to keep carrying it like the other ones.
All right, this then shows you how to add, subtract, multiply, and divide fractions. What I'll do on the rest of the tape is look at scientific notation. All right, let's look at scientific notation.
What scientific notation is saying this. 30 is the same thing as 3 times 10. So that's 3, we put a decimal right there, times 10. 10 is the same thing as 10 to the first power. Well, look here, 200 is the same thing as 2 times 100. 100 is the same thing as 10 squared. So what we can do is change 200, and we'll move the decimal place over there 2 places. Well, look at that. Now look, 4,000. 4,000 is 4 times 1,000. 1,000 is the same as 10 third. Look right here. If I start the decimal place right here and say I'm going to go behind the first non-zero digit, there's 1, 2, 3. So this power right here ends up being the number of places you move the decimal from where it is in the original problem to get behind the first non-zero digit. Well, let's see if that checks down here. I'm starting here, and I'm moving 1, 2, 3. Sure enough, that's what that number is. So then in scientific notation, what we can do then is this. We can take the number, move the decimal place over here behind the first non-zero digit, and rewrite it as powers of 10. Powers of 10. Well, what I have written here about R is this is the way they write it in the test and examples and books and stuff. So I want you to see that this is the same thing. This means 4 times 10 to the third, 2 times 10 to the second, 3 times, well, this is the same thing, 4 times, 2 times. So get used to seeing it this way on test exams and worksheets and so on. Well, let's look at some other examples. So we have 247. We want to change it to scientific notation. All right, how many places do I need to move it here? 2. So this would be 2.47 times 10 squared. Uh-oh, we got a different. This would be 2.47 times 10 to the minus 1. This would be 4.513 times 10 to the minus 2. Oh, do you see the connection? What it means then is this. If I have to move it this way to get there, it's a plus power. If I have to move it this direction, then it's a negative power. And what a negative power means is 1 over 10 of the first power, which would be 1/10. Sure enough, that's 2/10. This would be 1 over 10 squared. That's hundredths. Sure enough, that's what this is hundredths. So what would this one be? This one has lots of zeros, so let's see here. You got to come this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. So that's 7.89 times 10 to the minus 9.
be careful on one like that, to make sure you count. Start here now and just count over until you get behind the first non-zero digit. All right, let's look at two other examples there that are on your notes, just to show you about some numbers that are talked about. First of all, our national debt is in trillions. So let's say that we have 1.5 trillion. What would that be with decimals? Well, let's see. That would be 1500. Let's put a comma here so that was counting. 0, 0, 0, comma, 0, 0, 0. Let's see what we have so far. This may be it, may not. There's thousands. What comes next? Millions. What comes? Oops. Hey, we still need some more zeros. So here's hundreds, thousands, millions, billions. Finally got trillions. So what is trillions? Trillions would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So trillions would be 1.5 times 10 to the 12th power. Look at that number, very, very large number. So happens it's a million times a million to get the trillions. All right, let's look at another one, a small number, and think something like this. I don't know the exact numbers, but the size, the mass of an electron is 1 times 10 to the minus 23, something like that. But just to get an idea of how small that is, minus means we're going to have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, and then a 1. Very, very small. Right? All right. Let's look at some examples of some other ones like you see on task booklets and that type of thing. In adding and subtracting or multiplying or dividing numbers with scientific notation. And here's how it works. If this 10 to the power is the same, then all you have to do is add these numbers. So the answer to this would be 6 times 10 to the 3rd power. Okay. If these powers are the same, really what this is saying, this is 4,000, this is 2 thousandths, therefore that would be 6 thousandths. All right, let's take one where the powers aren't the same. What we do here is we take the 2 and take one of those 10s over and make it 10 to the 3rd. So 10 times this 2 is 20. We take one of the 10s out here and multiply it times that, and then that gives us 10 to the 3rd plus 4 times 10 cubed, and now that adds up to 24, 10 cubed. Okay? Or we could write this as 2.4 times 10 to the 4th power. In other words, we can move a 10 in here by multiplying the in or out and change. You need to know that in case of the multiple choice, this one is the answer rather than this one. You need to know the difference between them. All you're doing is taking a 10 here and dividing it in here, moving it over here. Or reversing it here, taking the 10 out of here, multiplying it, you get that. All right, let's look at an example where we're going to multiply now. This is totally different, totally different, totally different. When we multiply the numbers out in front, so that will be 8. And then that will be 10 to the 6th. Here's the big difference. When you multiply this, you multiply the numbers out in front times the numbers out in front. Write that down. And then you multiply 10 to the 3rd times 10 to the 3rd.
Now, 10 to the third is 10 times 10 times 10. 10 to the third is another 10 times 10 times 10. And how many of these do we have? 1, 2, 3, 4, 5, 6. Oh, we have 6 of them. It's not 9. You don't multiply the powers. When you multiply 10 to the power times 10 to the power, you just add these. 10 to the 7th times 10 to the 6th is 10 to the 13th. So remember that. All right, let's look at another example. The next example in your notes, 9.41 times 10 to the 7th times, that's what this means, times 3.8 times 10 to the 3rd. Here's how you work it. Remember I said multiply numbers times numbers. So we've got to come down here and take 9.41 times 3.8 and multiply that out. So that's 8. 8 times 4 is 32. Carry on 3. 72, 3 is 75. 3 times 1 is 3. 3 times 4 is 12. Carry on 1, 28. So adding this would be 8, 5, 7, 15, carry on 1, 3. Remember from the previous part of this tape, there's 1, 2, 3. So come over here 3. So let's go back up here and we'll say, all right, this answer is 35.758 times 10 to the what? 10 to the 10th power. 10 to the 10th power. So really this answer is very, very large. We have to move this place over to 10 places. So it's 357 billion. Very, very large number. Hey, we could write this as 3.5758 times 10 to the 11th power. See, what I'm doing is taking a 10 out here, dividing a 10 out here, and putting it over here. 10 more, 10 times this makes 1 more 10. So either way they write on it as your choice on a task test, you should know either one of those is the same answer. All right, now let's look at division with scientific notation. Well, here we have one. Our rule is what? When we're adding these and these are the same, then we can just add the numbers in front, and then that's 10 to the 3rd. On the bottom, hey, this is a one of these, not nothing there. That's 3 of these and 1 of these, so when we add, we get a 4 of those. Well, let's see, we can divide 2 into this, it'll go 2 times. 2 will go into this 3 times. And 10 to the 3rd will go into this 1 time. And 10 to the 3rd will go into this 1 time. So we have 3 over 2. All right, now let's look at another one. We have 16 times 10 to the 3rd over 20 times 10 to the 7th. So let's see, well, we do our numbers. See, 4 going to this 4 times, 4 going to this 5 times. So over here, we're going to have 4 over 5. Uh-oh, these aren't the same. So here's what we do. You remember when we multiplied 10 to the power times 10 to the power, we added. When you divide, you subtract. So what I'm going to do is divide 10 to the 3rd out of this, and that'll leave 1 time. And here, dividing out will be 10 to the 4th, because I subtract powers. So what I have left on top is a 1, and what I have left on the bottom is 10 to the 4th. And here's the last thing I want you to notice. 4 divided by 5. Remember, go over and do long division. That's 0.8. And then this is times 10 to the minus 4. 10 to the minus 4. Now I want to show you a better way of doing it than the way I did it on the board right here. I don't think this is the best way. I wanted to show you what's happening. But here's what I'd like for you to see. You come back over here and you have 10 to the 3rd divided by 10 to the 7th, and you subtract. What is 3 minus 7 to minus 4? So you're simply down, write down 10 to the minus 4. And that's sufficient. However,
on an answer, they might have something like this. This is 10 to the minus 3, or, be careful, watch out, let me show you. Let me show you what this is. 10 to the minus 4, and this says I've got to have a decimal that way. So the answer to this would be 0.00008. I'm moving in 4 places. From here, I'm moving in 4 places. 1, 2, 3, 4. So if I want the 8 here, if I want to start from here and move it to get there, I've got to move it what? 5, not 3. So starting here and going, I get the same answer. All right, this concludes the notation on decimals and scientific notation.